Hello, conference. So my name is Oleksii Shatalov. Please, next slide. I have 2 years of professional industrial experience in the customer and production application lives and projects. So extra 3 years on the scientific research at the laboratory of my university, several Scopus indexed articles, and also I'm a passionate machine learning engineer and data scientist that develop new technologies, and like it's interesting for me. That's just an interesting thing. Next slide, please. So here we see a quick roadmap of my report. Here we are going to define the business problem that we are going to solve. The next slide and the next part will be in the introduction. Then we will review the existing solutions for such a problem solution. Then we are going to discuss a method to apply. We will review the multilinguality problem, and then we will make some conclusions. Next slide, please. So the main business problem we are going to solve is the finding of documents or portions of the documents in a particular sample that bear a direct resemblance to the document in whole or in some parts. So we have like a storage of documents, we have like the input as one document, and we are going to find the most similar document or maybe parts that satisfied for us as be the similar parts for the parts of the input document. Next slide, please. So we are going to make 2 stages for our system. That's an indexing stage, and then the search stage, making the index, the first stage, and then performing the search at the second stage. Next slide, please. So we already have several methods and technologies that we can apply during our work and developing our system. That's for the pure text-based methods, TF-IDF and the copy BM25. On the top of the TF-IDF, then distances, different distances, and W-shangling. For the vector-based, we have like the DL models involved. For some solutions, some bag of words, the Pearson correlation coefficient, different similarity distances measures, and etc. Next slide, please. That's the main solutions that we already have. So in TF-IDF, we are going to like find the parts of documents or some documents by performing the processing of the query, which is n-gram that we are going to process, and n-grams that we collect from the documents that's already in the storage. And then it's like the making some footage of this, and if we find the suitable for us document that has a measure near by the text by this TF-IDF score, then that the document or the part of the document will satisfy us. Next slide, please. The distances usually involve the different parts of the text as is. So we like taking into account only the words or different sentences that has been written by someone, and measuring the distances, the differences of the writing these words. So for example, here we see the distance 1, where we have some information here and some information there. We see that in the second part, we have added the letter T that caused the distance measure as 1. Next slide, please. Next, we have the W shangling. It maybe also could be related to some distances, as it measures the overlapping sets, the part of those overlapping sets to the wall united documents, as you can see from the formula. Next slide, please. And the vector based. So we are going to input some different documents for our deep learning model, or maybe not deep learning model, some model that create the embeddings in some multidimensional vector space. And then we are going to measure the similarity of the documents by measuring the distance between them in this multidimensional, vector space. Next slide, please. So our solution that we are going to propose is for indexing, create the vector representation for all documents inside the corpus. And the search will involve finding the nearest biovector similarity document that we have already in the storage. The main question is speed. We're going to discuss it a little bit later, so in the next slides. Because we may have no, it's not we are going to discuss here, but it's not like that. As we may have inside our corpus data the billions of documents that has several hundred words or several hundred sentences even, that we are going to index and process. And even for the big data, it's quite a large amount of data for such a systems. Then we are going to perform the pure text, involving also for finding the nearest text, and that's suitable for us. That's pure text also indexing, and the pure text finding, but involving some prefiltration. And about it we also are going to discuss. And also we are going to make some approach to perform the partial match. So when we have only matching the part of the document, but not of all the document. And the same is for the query that we're going to use. Next slide, please. So the basic pipeline that we're going to implement and we are going to use is the first one, the index documents itself and their parts. For example, sentences, it's maybe, for example, some paragraphs or maybe some chapters as vectors and pure text. Then the second step is create representations of the input documents and its parts. Then we should compare document and all parts to the indexed data. Then we should range the results by similarity score and make the final results accessible to the person or other pipelines. Next slide, please. So the first topic we are going to discuss is optimization. So to perform the increasing the speed of our system, both in indexing and in search, we are going to perform the clusterization, primary clusterization for our vectors that we have already in some database or some storage. It doesn't matter. It can decrease the number of vectors for the primary search we are going to find. So firstly, by the query, the input document, we will find the centroids of this clusterization, making some hierarchy, and then from the nearest centroids, we will perform the search in these clusters by measuring the distance for each of the documents only in the certain the nearest clusters. And then the second point we are going to discuss is the search with parts of the documents. So primary, we should compare only documents itself, but then but then we should like split it to the pieces that has some relation to the primary documents, and then perform the part-to-part search inside these data, making such kind of a top-down approach. Next slide, please. So here you have the primary architecture for indexing. We have a set of docs. Then we have the preprocessing for this set of docs. Then we have the multilingual language model that should resolve the problem of the multilinguality search. And then we put embeddings of our documents to the index and to the storage. Making the backpropagation, let's say, of our metadata. Next slide, please. The search process will be applied in the combined way, as I have mentioned. It involves both the neural networks and deep learning with the multilingual language model and the pure text with the translator API. With the translator API that involved the performing the pure text search with the primary algorithms that we used, copy BM25. So we firstly should filter our data from storage and index. Then we should put them inside some filtered storage that we have already in our system, and then we should filter also from this data the most similar data by measuring the distances to the text, the pure text that we obtain from the translator API, as we may have the language that differs from the language inside the input text. And after that, we have the scores, the special scores that may allow us to range the obtained results. Next slide, please. Our storage and index look like this. We have the connection by the primary key linking here. So we have some data stored in the storage and the index. The storage you can see on the right side of the slide. So it's the pure SQL database, let's say, the pure tabular data that we have. So we have the embedding, we have the metadata, and we have a text. Metadata that we are going to use for the filtering, the text that we are going to use for the search, and the embedding that we stored here after the indexing process by the multilingual language model. So the index is some kind of the united clusters with the cluster centroids in both of what we are going to perform this search. And yeah, I think that's all for this slide. Next slide, please. So our conclusions. We found a solution for the problem, made the review of the existing methods, and optimized the solution for the production work. Next slide, please. Thank you very much. That's all from my side. Any questions?
That was really good. Thank you. Thank you. So questions? We don't seem to have any questions here. Okay, so can I ask a question then?
Okay, yeah. Sure.
Yeah, so you talked about bag of words. When, let's say if you are doing it for a human resource or HR application, right? And we're looking into experiences such as the experience can be negative experience, positive experience, or experience with the customer. So how would you extract those information clearly?
I think that this information should be extracted mostly with other methods of the information retrieval, as we have here the system that measures and finds the similar documents, mostly not the obtained information from the storage by the query. But I can answer for your question, as it not mostly related to the topic of my report. We may use some kind of named entity recognition here. Uh, I have done the project with these resumes and CVs for people and extract information that's also related to the experience in the industry from here. And I should answer that we had F1 score using the standard pipeline from Spaces named entity recognizer. So firstly, we should find some keywords that can describe mostly the surrounded information. So, for example, years of experience or industrial experience or whatever we have inside the text. And then we should apply some customization for the years and to measure the period of time, as, for example, different customers include the information about hours, not even the months or years or days, the hours, working hours of experience. It can be derived, for example, for several millions or maybe several thousand hundred. And that's why we should build this pipeline, I think, here.
Yeah, thank you. Anyone? Oh, yeah, there's one more question.
Yeah, there's been a lot of research about, for example, resumes. When people use scrapers on resumes, the ones that are kind of really fancy kind of formatted, scrapers really struggle on these just because of the formatting issues. Whereas really simple resumes, it's easier for scrapers to get the information out of that. And I was wondering on your documentation kind of comparisons, is that taken into account, like formatting issues and stuff?
So as I understood, I had like the bad louding from you. As I understood, the main point here is about the formatting, text formatting that we have inside the documents during the indexing and during the search of data. Yes, am I right?
Yeah.
Yeah.
Sure. For this, can you please return to the indexing pipeline slide? I think it's 14th. No, well, yeah. Stop here. It's settings. So we have before to perform the indexing with the help of our multilingual model. We should firstly perform the pre-processing to our text. So we should delete all information that not interesting for us. That maybe, for example, could be some links to whatever we have. It can be, for example, some different symbols that not for the data data implementation in text. So, for example, uh, some different symbols that not the letters, numbers, points, commas, etc. That has a context and may represent the feelings and the information from the person. And also, and only then we should apply the multilingual models to encode our documents. And the same is for the search process. So we have like this window of the pipeline also here in our search pipeline. So next slide, please. We also have, as you see, the point from the input file to the processing, pre-processing, and here we should perform the same tasks. So the different formatting of the text will not be the issue for our system, as we as we should like make the unified tagging for our documents themselves.
Any other question? Okay, so Oleksii, we have got a lot of students here, as well as people who are already in IT or in other jobs who are planning to move to AI. So can you tell us your day-to-day experience? What is it like? What do you do?
Sure. I'm working in the outsourcing company in Ukraine. My day-to-day work is like making some products for the customer. I'm working as an outstaff machine learning engineer at one company where we like making some applications related to the natural language processing with the rest of the team from different countries. I'm sorry if some definitions from my side are too smoothly because I have like an NDA, so I cannot like discuss some information from my main work. But the main work includes mostly building the solutions that's based on the large language models. As you mentioned before, that's GPT, that's a Bear, Distelbert, XLMR, Roberta, and other different popular large language models. Also, we apply some different rules in the connection with the simple linguistics, let's say, and linguists, the specialists in linguistic area, not in the computer linguistic, but in the linguistics itself. Also, we have like the cloud platform where should define some different architectural solutions with the help of containerization of our applications and performing some optimization for our platform to make the wasting money not so much to our research, but mostly my department where I'm working now, my department where I like the part of the team. We are like the R&D department, so we have like the true fly of our mind. We can implement whatever we want, and we have no the strict predefined deadlines, let's say.
Great, thank you. Thank you so much, Oleksii. Thank you again.